In topic 2, we're going to talk about factoring out the GCF. Now remember, our goal is to write a polynomial as a product, very specifically the product of two or more polynomials of lesser degree. Okay, now the steps. Okay, first thing we're going to do is we have to determine what the GCF actually is. That kind of should make sense to you. Figure out what the GCF is of all of the terms of the polynomial. Next, we're going to divide each term of the polynomial by the GCF. So essentially, factoring is kind of like division with polynomials. We're undoing what we learned in the chapter where we were multiplying polynomials. So what we're going to be doing here is we're basically going to be undoing the distributive property. Well, the distributive property allows you to multiply through a sum or a difference. Well, here we're going to be dividing that out, okay? So this is basically going to be undoing the distributive property. Now, once you have your GCF and you divide all of your terms by your GCF, what then? Well, we have to write our answer as a product, the product of the GCF and the result you get from that second step, okay? So example 2 says factor out the GCF. So part A, we've got two terms. We've got 5x squared and 20. Well, I noticed right off the bat that both terms do not have x's, so our GCF is just going to be a number here. We're not going to have a variable in our GCF. So we want to look at 5 and 20. Well, looking at 5 and 20, is 5, the smaller of the two coefficients, is 5 a factor of 20? Yes, it is. So in this case, we would say the GCF is 5. Okay, that's easy enough. So now I want to take each of the original terms in the polynomial and I want to divide them by 5. Okay, now we have to be ready for our answer. Our answer is the actual GCF times whatever is left when we divide by the GCF. So looking at the first term, I have 5x squared divided by 5. Well, 5 divided by 5 is just 1, and 1 times x squared is just x squared. So we're left with x squared. And then 20 divided by 5 is 4. And because it's positive, I'm going to go ahead and put plus 4 here. And this is my final answer. Now, if I wanted to check this, I could. I would just distribute. So I would say, okay, I'm going to distribute 5 times x squared plus 4. So I'm going to multiply x squared and 5 by 4. Well, 5 times x squared is 5x squared. 5 times 4 is 20. And if you look at this right here, it is exactly what we started with, okay? So we've proven that we really are just undoing the distributive property. So anytime you factor out a GCF, it's just the distributive property in reverse. Okay, for part B, we have 9x to the third, 6x squared, and 12. So let's look at just the 9, the 6, and the 12. Well, I always start with the smallest of the coefficients, which would be 6. Is 6 a factor of 9 and 12? Well, 6 is a factor of 12, but it's not a factor of 9. So I then want to start looking at factors of 6. So factors of 6 would be 3 and 2, and I always go biggest to smallest. So the biggest factor of 6 is 3, okay? Well, other than 6. The biggest factor that is not 6 would be 3. Is 3 a factor of 9? Yes. Is 3 also a factor of 12? Yes. That means my GCF so far is 3, okay? Now we need to look at x to the third, x squared, and x. And remember, when you're dealing with variables, you have to look at the number of variables that's common to all three terms. Well, if I look at x to the third, only one of these terms has 3 x's, so that can't be the GCF. If I look at x to the second power, only 2 of the terms have 2 x's, so that can't be the GCF. I have to look at just plain old x. That's the smallest number of variables common to everything, okay? And it is common to everything. All three terms have an x. So my GCF here would be 3x, okay? So I'm going to get ready for, well, let me rewrite that a little bit higher. So my final answer is always going to be the actual GCF times whatever is left when I divide the polynomial by the GCF. Remember, this is like division with polynomials, kind of. So I'm going to take each of these terms and I'm going to divide them by 3x. So looking at 9x to the third divided by 3x, 9 divided by 3 is 3. And then you have to kind of go back to that idea of the quotient rule. The quotient rule says if you're dividing two expressions that have the same base, you keep the base and you subtract your exponents. So I have x to the third divided by x. Well, they have the same base, so I'm going to keep the base, which is x, and then I'm going to subtract my exponents. My exponents being 3 and 1. Well, 3 minus 1 is 2. Okay? And then I just go to the next term in the polynomial. 6x squared divided by 3x. Well, 6 divided by 3 is 2. And then x squared divided by x, again, we're going to use the quotient rule. So we have two things that are being divided with the same base. I keep the base. I subtract my exponents. 2 minus 1 is just 1, so I just write it as plain old x. All right. And then finally, I have negative 12x divided by 3x. Negative 12 divided by 3 is negative 4. And then x divided by x just becomes 1, and negative 4 times 1 is just negative 4. So this right here is our final answer. And if you want to check it, you can. We would just check by distributing. Now, you don't always have to check, just know that you can check. So I'm going to show you this one for checking, and then we won't worry about checking for the third one. So 3x times 3x squared, well, 3 times 3 is 9. And then x times x squared is the product rule. The product rule says if you multiply two things with the same base, keep the base and add your exponents. Well, I keep the base of x, and then I add my exponents of 1 and 2, which is 3. And then I go to the next. 3 times 2 is 6. X times x is x squared. And then 3x times negative 4 is negative 12x. And just like in the previous example, this right here is exactly what we started with. So we're just checking that this really does work. Again, you don't always have to check, just know that you can check, okay? Part C, we are looking at 12, 8, and 4. So I always start with the smallest coefficient, which is 4. Is 4 a factor of 8? Yes. Is 4 a factor of 12? Also yes. So far, my GCF is 4. Now let's look at the x's. Do all three terms have x's in common? Yes. We need to find the smallest number they all have in common, or well, really the greatest number they all have in common, which ends up being the smallest exponent. So right here, I see that I have one x in my 4xy term. I also have an x in 8x squared y. I also have an x in 12x cubed y squared. So my GCF has an x. And then ditto for the y, I have at most one y that's common to everything, so I can only include y to the first. So remember, when you're dealing with the variable portion of your GCF, you're looking for the smallest exponent because that's going to be the greatest number that's common to everything. So they all have a 4 in common, and they all have at least a y and an x in common. So my final answer is going to be 4y times whatever I get when I divide each term by 4, not 4y, 4xy, excuse me. So my final answer is going to be the GCF of 4xy times whatever I get when I divide each term in the polynomial by the GCF, which again is 4xy. So 12x third y squared divided by 4xy. 12 divided by 4 is 3. X to the third divided by x. Remember, we keep the base, we subtract the exponents, we're going to get x squared. And then y squared divided by y is just going to be y to the first. 2 minus 1 is 1, so we just get a single y there. Now, negative 8 divided by 4 is negative 2. X squared divided by x is x. Y divided by y, well, those y's, we say they cancel, but really it just divides to be 1. So negative 2x times 1 is just negative 2x. And then finally, 4 divided by 4 is 1. X divided by x is 1. Y divided by y is 1. So I'm just left with a plain old 1 right there. You have to write the 1. If you forget the 1, your answer is not correct. Okay, so that's factoring out just a regular old GCF. But there is going to be something that we talk about in just a bit where what we're going to be factoring out is a binomial. So let's practice that really quick. So for example 3, it says factor out each binomial factor. So please notice, if we look at part A, what's common to these two terms is x minus 1. So if we kind of split this right here, those are the two terms of this polynomial. We have x squared times x minus 1, that's our first term, minus 2 times x minus 1, that's our second term, okay? What's common to these two terms, again, is the x minus 1. So my GCF here is x minus 1. So my final answer is going to be x minus 1 times whatever I get when I divide both of these terms by x minus 1. Well, looking at x squared times x minus 1 divided by x minus 1, the entire x minus 1 is in parentheses, and that's what we're canceling out. That's what's dividing out and becoming 1. X minus 1 divided by itself is 1. 1 times x squared is x squared. So that's what's left for the first term. The second term, I have negative 2 times x minus 1 divided by x minus 1. Well, the x minus 1's in parentheses cancel entirely. So x minus 1 divided by itself is 1. Negative 2 times 1 is negative 2. So this is my final answer. And then finally, for part B, what we have in common here is the x squared minus 2. So my GCF is x squared. I think I said x squared minus 2. I meant x squared minus 7. So my GCF is x squared minus 7. So my final answer is going to start with x squared minus 7, the GCF. And then I'm going to be left with whatever happens after I divide both terms by the GCF. So my first term is x to the third times x squared minus 7. My second term is 3 times x squared minus 7. I'm going to divide each of those by x squared minus 7. So the entire factor is x squared minus 7. So in the first term, x squared minus 7 divided by itself is 1. 1 times x to the third is x to the third. In the second term, x squared minus 7 divided by x squared minus 7 is 1. 1 times 3 is 3. And this becomes our final answer. And I show you this because I promise it's coming up soon. It's going to come up in something called factor by grouping.